Alright everybody, let's talk about lesson 6, which is colligative properties. Okay, colligative properties are the properties that depend on concentration of the amount of particles you have, not what they are. So we have two types of colligative properties that we're going to talk about. Boiling point elevation and freezing point depression. So let's talk about boiling point elevation. So boiling point elevation means that your boiling point is going to increase when you add solute or a solid to your solution. So for example, when you add salt to water, instead of boiling at 100 degrees Celsius, it's actually going to boil at 102 to 103 degrees Celsius. This is because those salt particles are going to block the water particles from being able to hit the surface and changing into the gas phase. So normal water boils at 100 degrees. When you add salt to water, you're going to change that boiling point because these ions are going to block the water from boiling and becoming a gas. Freezing point depression is the opposite. That's when the freezing point will decrease when you add a solute. So that, for example, is why we put ice, and during when it's icy outside, we put salt on the roads. Because when we put salt on the roads, it'll actually drop the freezing point of water to below 0 degrees Celsius. And that's because the intermolecular forces that will attract those water molecules together to become a solid are going to be interrupted by those salt molecules that are going to get in their way. So again, normal water is going to freeze at 0 degrees Celsius. Water with salt in it actually freezes at negative 20 degrees Celsius. Because of the properties that has, that's another reason why we put antifreeze in our cars in the winter, so that all of our liquids and fluids in our cars don't freeze. So, remember we talked about the fact that the identity of the particle doesn't matter, it just matters on how many you have. So, for example, when this dissolves in water, it's a molecular compound. It only is going to break up into one particle. When NaCl dissolves in water, it's going to break up into two particles, Na plus and Cl minus. So you're going to have an even greater effect on the boiling point and the melting point. And when this dissolves in water, you're going to have an even greater effect because you get three particles in solution, two Na pluses and one CO3 minus. So you are going to have a higher and a lower boiling point when you're using Na2CO3 because of the fact that you have three particles in solution as opposed to two or one. Let's look at check your practice. Which compound, when dissolved in water, will have the highest boiling point? Pause the video, unpause when you're ready. Well, the first thing you need to do when you look at these problems is you have to look at your choices. A is an ionic compound, B is an ionic compound, and D is an ionic compound. C is a covalent compound, so it's only going to stay as one particle, so that's not going to work. Both B and D are only going to dissociate into two ions, so that's not going to be enough. A actually dissociates into three ions, one Ca2 plus and two Cl minuses. So this is going to have the highest boiling point because it's going to change your boiling point the most. Now let's check your understanding. We'll answer this first thing tomorrow in class.